Now we'll discuss the important part of matter chapter and the last part also, that is change in state of matter. So by see the heading only, you have understood that here we are talking about state changing. Okay, so there are three states we have just learned. One is solid, one is liquid, and another one is gas. Okay, so by which process, okay, the solid is changed into liquid or liquid is changed into gas, that is known as change in state of matter. Okay, that is known as change in state of matter. And now the question will come, how it will be changed? Definitely, to change the state, we need to give heat energy. Okay, to change the state, we need to give heat energy. So if we give heat energy to solid, it will convert into liquid. If we give heat energy to liquid, it will convert into gas. So plus heat. But if I have taken heat energy from gas to liquid, minus it, then it will convert into liquid. If I have taken heat from liquid, then it will convert into solid. So this is the whole process where the solid will convert into liquid and liquid will convert into gas due to the imparting of heat energy to it, but the important thing is that temperature should be constant. That is known as state change of matter or change in state of matter. Now you will be little confused. Sir, we have given heat energy to a body, but its temperature should be constant. How it is possible? Let's see and discuss how it is possible. As you know, I am talking about the solid. We know the molecular model of solid. Okay. And they are very much closely packed. They are not moving here and there. So if you have given heat energy to it, then what will happen? Now we know when the heat energy is given, the vibration of the particles in solid, it will be increased because the particles cannot able to move. As they cannot able to move, the solid's vibration will be increased, and you have given more heat energy, more vibration, more temperature. Try to understand it. It is a very interesting concept. If you have given more heat energy, more vibration, more temperature. So temperature will be increased as you have given heat energy to a solid. But it will reach at an ultimate point. By increasing the temperature, it will reach at the maximum point. At that maximum point, okay, the temperature should be constant, and that time we will see at that constant temperature this solid should be converted into liquid. Why it will be converted into liquid? Simple thing, you have given more heat energy means more vibration, and due to this more vibration, suddenly what will happen? Now the intermolecular forces will decrease. We know the intermolecular forces are maximum for solid, but as you have given heat energy, this heat energy try to vibrate it more, and if you vibrates more, the intermolecular forces will decrease, and at the maximum point, when at a constant temperature, the intermolecular forces are so less that it will convert into liquid, and that time the molecular model will be like that. Means the particles are moving here and there. The strong attraction, the strong packing of molecules will be lost. That is change of state. And here we have seen the state change of state occurs from solid to liquid. It is occurred solid to liquid. The state is changed. This solid to liquid state changing is known as melting. You are quite familiar with the term. It is not like that a new term for you. This is known as melting. Okay. And the constant temperature when the melting is occurred, this constant temperature is known as melting point. Don't be panic. I'll give example for it. So what we have seen, that at constant temperature the solid is converted to liquid when the heat energy is given to it, and that procedure is known as melting, or there is a name also, another, fusion. Okay, the process is known as melting or fusion. Okay, and the constant temperature on which you have given the heat energy, that is known as melting point. Clear? I think it is clear enough. If I have done the reverse process, what is the reverse process? If assume it is liquid, I have taken heat from it. I have taken heat. So as you have taken heat energy, the kinetic energy of movement of the particles, that will be decreased. More heat energy is taken, is drawn out from it. More heat energy, more kinetic energy will be decreased, and at a constant temperature, that liquid should be converted into solid. That liquid is converted into solid, and that process is known as freezing. We all know about the freeze, na? Refrigerator, it is there in our home, and there we have seen that freezing is a process where the liquid is converted to solid at constant temperature when the heat is taken out from it. Heat is taken out or drawn out from it. This is known as freezing, and the constant temperature is freezing point. So in generally, for a solid and the liquid of same substance, melting point and freezing point should be same. Melting point and freezing point should be same. Let's see an example. What is the example we'll see? If I'm talking about ice. Okay. So ice, assume the ice is at minus 10 degrees centigrade. Now you have given heat energy to it. So as we have given heat energy from minus 10, it will come minus 5. So heat energy is given. Okay, temperature will be increased, minus 10 to minus 5, then minus 2, and assume it is coming then 0 degree centigrade. At 0 degree centigrade, then if you have given heat energy also, the temperature will not exceed. Temperature will not exceed. What will happen? Now, at 0 degree centigrade, the solid, means the ice, should be converted into water. The ice should be converted into water. If it is an ice cube, it is converted into water when at 0 degree centigrade. But heat you have supplied. Heat supply, when whatever the heat you have given, that is not stopped, but temperature will not rise. Okay, and that temperature is known as melting point of ice. Or you can say in another way, if you have taken heat from water, at 0 degree centigrade, it will converted into ice. If you have taken heat, minus heat, and that is the freezing point. and the freezing point of ice is also 0 degree. Melting point and freezing point should always be same. Okay, I think it is clear enough. Okay, so you have understood how a solid is converted into liquid and how a liquid is converted into solid. And now one thing I am telling you, it is very much clear. Just try to understand that at 0 degree centigrade you have given heat energy to the body. You are not stopping the heat energy, but temperature is not increased. Acha, at 0 degree centigrade temperature, how much heat energy you have to give to convert a solid to liquid? At 0 degree centigrade, how much heat energy you have to give from ice to water? So for ice to water, for 1 kg of ice, 336 into 10 to the power 3 joule of heat energy is needed to change the state at 0 degrees centigrade. Means the temperature is at 0 degrees centigrade and you have converted 1 kg of ice to water. Okay, you will need 336 into 10 to the power 3 joule of extra heat. And if you have taken that heat from water at 0 degrees centigrade, it will convert into ice. And this heat energy is known as latent heat of fusion. This heat energy is known as latent heat of fusion. Clear? Many more things I have told. Okay, just make a single line and try to understand. Number one, the process when solid is converted into liquid at a constant temperature, it is known as melting. The constant temperature, it is known as melting point. Here for the case of water, ice to water, it is melting point is 0 degree centigrade, and at this temperature the heat energy is needed to convert the state, to change the state. It is 336 into 10 to the power 3 joule, which is known as latent heat of fusion, because this heat is needed to change the state. Why it is needed? That you have to learn little later, not in class 6. Okay, that you will learn little later. For class 6, this is more. Okay, so whatever the notes I have given, only read that portion, that is enough. But this one I have given for your knowledge. Now I have to come in next step. If liquid is converted into gas when heat energy is given to you, that process is known as boiling. That process is known as boiling. So we can say that the process by which heat energy is given to a liquid and it is converted into gas at a constant temperature, that is known as boiling. It is having another name also, that is vaporization. Boiling or vaporization. Okay, so you can say boiling, you can say vaporization, both the process are same. Okay, if I am talking about the reverse process, in which process when heat is taken from the gas and it is converted into liquid, that process is known as condensation. Okay, so we'll see an example for it. We all know that if I'm talking about the example that water is converted into steam, assume the water is of 50 degrees centigrade. Okay, you have given heat energy, it will increase to 80 degrees centigrade. You have given more heat energy, it will come to 90 degrees centigrade. you have given more, it will come 100 degrees centigrade. If you give more heat energy, then this temperature will not increase. It will not come 100 degree to more or more than that. Okay, 100 degrees centigrade should be fixed there, and in 100 degrees centigrade it will convert into steam. Okay, 100 degrees centigrade it will convert into steam. So that temperature, this 100 degrees centigrade, that is known as boiling point or vaporizing point. Okay, boiling point. Clear? Okay, so the temperature, the constant temperature when water is converted into steam, that is known as 100 degrees centigrade, and that is the boiling point of water. And in reverse order, if you have taken heat from the steam, assume the heat is, assume it is 150 degrees centigrade. You have taken heat, it is 120 degrees centigrade. It is, you have taken heat, it is 100 degrees centigrade. Now, if you have taken heat also, the heat of steam will not the temperature of steam will not decrease. The temperature should be constant at 100 degrees centigrade, and if you have taken heat, the steam will be converted into water, and that is condensing point also. Same thing. Now the question has come, how much extra heat energy you have to give to water to convert it to steam at constant temperature 100 degrees centigrade. Okay, that we have seen here now, that how much extra heat energy you have to give to water to change to steam at 100 degree centigrade. So that value we have to write down. So I am erasing this one. So we can say at 100 degree centigrade for 1 kg of water, 2260 into 10 to the power 3 joule of heat is needed to change it to steam. At 100 degree centigrade for 1 kg water, to convert it in steam, means 1 kg steam, definitely 1 kg of water to 1 kg of steam, you need 2260 into 10 to the power 3 joule of heat energy extra, and that is known as latent heat of vaporization. Latent heat of vaporization. Okay, so this is the whole process. I think it is clear enough for you. Okay, change in state of matter. And now I'm giving you a last part, that why the state is changed. Simple thing, as you have given more heat energy to a liquid, then the kinetic energy of the liquid will be more, and at a certain point the kinetic energy is so much that we cannot able to control, and the water cannot able to control, because as more kinetic energy is coming, we have to write here more kinetic energy, less intermolecular force. And as intermolecular force is decreased, it is converted into gas, and less kinetic energy means more intermolecular force. In reverse way we can say that. Okay, that is change in state, and it is explained in a form of molecular model also. Okay, so it is clear enough. In molecular model for solid, it is compact, more heat energy given, more vibration, less intermolecular attraction, it is converted into liquid. You have given more heat energy, then more kinetic energy of the molecules, it is converted into gas because of less intermolecular force. You have taken heat energy, the gas is converted into liquid. You have taken heat energy, liquid is converted into solid, as less the heat energy, less kinetic energy, more intermolecular force. Okay, this is the story of change in state of matter. Okay, what notes I have given to you, just read that notes. I think it is enough for you. Okay, thank you.